Hi, I'm Tony from HomePop Gaming, and welcome to this episode in the series of design patterns. Do you ever feel that your game's logic is spiraling out of control? One moment your NPC is walking, the next it's stuck in attack mode, or just doing nothing at all. If you're tired of tangled if-else statements and buggy transitions, it's time to level up your code with the state pattern. It's a powerful design tool that'll keep your game logic clean, scalable, and smooth. Whether you're new to game development or building your dream project, this pattern can change the way you think about NPC, player actions, and game mechanics. Now, this video does assume that you understand OOP and Lua. If you don't, you can check out my previous video. I've added a link in the description below. So what is the state pattern? It's a behavioural design pattern that allows an object to change its behaviour when the internal state changes. What this means is if you're working on a game and you want your objects to behave dynamically, so for example, they should be idle when there's nothing to do, or they walk when patrolling and they attack when a player's nearby. At first you might think, hey, I'll just use some if-else statements. And that's fine while your game's small. But as your game grows, new behaviours will be added. This approach will quickly become messy. Every time you update the game logic, you'll have to dig through layers of conditions. It's not just messy, but it's hard to maintain, it's error prone, and it makes it really difficult to test. Now, this is where the state pattern comes in. The state pattern organises your code by encapsulating each behaviour into its own object, making it modular, flexible, and easy to expand. Today, I'll show you how to implement the state pattern into your games. I've got some code set up, and I'll paste each bit in and explain what it's doing as we go. This way, you get to understand what the code's doing, and you don't need to sit and watch me type. Let's start by looking at an example that tries to manage state. So I'm going to add a new script and just paste in a really basic NPC. You can see what we've got here. We instantiate the object and we set the state property to idle. We then have a method called update, and this says if this NPC state is idle, then we're going to print that it's standing still. If it's walking, we're going to print it's walking around, and if it's attacking, we're going to print that it's attacking the player. Otherwise, we're going to say the state's unknown. I've just added a comment here because in a real game, you wouldn't be printing to the console. You would be putting in your logic for movement or your logic for attack, but that's beyond the scope of this tutorial. Then down at the bottom, what we do, we set the state to walking and we call update, and then we set it into attacking. And if we run this, we'll see that the NPC is walking around and the NPC is attacking the player, just as our script says it will do. Now, this code does get the job done, but as usual with any tutorial code, it's oversimplified. In each of those states, you'd want to be doing a lot more than simply printing out to the console. Another problem is if you add more states, which you will do as your game grows, this is going to get hard to maintain really quickly. So let's refactor this code to use the state pattern. What I'm going to do first is create a folder, and we'll call this V1. In here, we can dump this script. Let's create a V2 folder, close this off, and what we need to do is add a module script. So this is going to be the starter for our state class. And what I've pasted in here is a thing called, I called it default state. Maybe a better name for it would be base state or parent state. But this is going to be the state that everything else extends from. In here, we've instantiated the object, set the index to be part of this object, and give the option to create a new instance of it. Then what I've done below here is I've created enter, update, and exit. Now you'll notice all of these methods throw an error. I do this to make it clear that any subclass of the default state is expected to implement its own version of these methods. So these are similar to abstract methods that you'll find in other programming languages, which means it's a base class with a method that subclasses must override. So next we're going to create three states, an idle state, a walking state, and an attacking state. These three states are going to implement the default state and override this enter, update, and exit functionality for each one of them. So in here, I've created my attacking state. It requires the default state, which remember is the parent, and then we set the meta table for attacking state and passing the default state. So this means that now my attacking state will also have access to the methods that are in the default state. We then create a new instance or rather we create a method to create a new instance of our attacking class, and then we override enter, update, and exit. Now, so this is where you put your logic if you was doing this for a real game. So for example, the enter state here might trigger some animation or combat logic, and it would trigger its own event to be emitted. And then I build the walking state in much the same way, setting the meta table, passing in default state, giving the option to create a new instance, and then override, enter, update, and exit. And as before, this would be where you put your game's logic. So in this particular case, this would handle any movement and emit an event to broadcast that the object's now walking. Finally, we have the idle state, same as the other two. What you'll notice with these classes is that I'm passing in the NPC. So let's create that now. So now we've created the NPC, and this tracks the current state and any transitions between states. The ability to manage state is the core of the state pattern. It handles the exiting of the current state, which is where the specific logic is ran, and calls enter on the new one, where once again some specific logic is run to get into that state. This means that every state can have its own transition and logic without affecting any of the other states. If we want to add a new state later, this becomes really easy to do. So let's run the code and see what we get. Let's stop that, because I've just realised I've got version 1 of the script running. We'll disable that. We'll add a new script in here. And what we'll do, at the top of this script, we're going to require our NPC and our 3 different states. We then need to create our NPC by calling NPC new, and we need to create each one of our states. So what we have here is an instance of the idle state, the walking state, and the attacking state. Now what we do, we call set state and pass in idle, and then call update. Next, we can easily change state, so we now have a walking state as well, and we can also transition to an attacking state really easily. I'll just check that this script is disabled and this script is enabled. I can see that from the icon. So we run it, and we can see here that the NPC is entering an idle state, now they're standing, and now they're exiting the idle state. Now they enter the walking state, they're walking around, and we go through the different states that have been set up in our code. What if you want to manage transitions between states? We may want to say, if you're in an idle state, you can move to the walking state or the attacking state. But we might also want to say, if you're in an attacking state, you can only go back to the idle state. So what I'm about to show you will very much depend on the scenario and if your game needs it. Never add more complexity to the code than what you need. The idea of the code is to make your game work, but in doing so, it often gets complicated. So what we try and do is simplify things. If adding extra code makes your game more complicated, then you're being counterproductive by writing it. Ultimately, we should be adding stuff that makes our lives easier in the future and gives us a more performant game, which makes it easier to change when we need to. What I'm trying to say is use this next option with caution. It may be right for you, it may not, but we'll go through it now. What I'm going to do is duplicate this v2 folder and change it to v3. So this is a copy of the NPC that we just created. But what we can do is use composition and add a state manager property to the NPC. If you want to know more about composition, I have a video which I've linked to in the description. So what we're going to do is start building our state manager first. Then we'll bring that in as a property for the NPC. But first, if you want to get a copy of this code, you can get it from our website. I've put a link in the description. While you're there, if you want to keep up with what I'm doing or any changes that I've made to the code, please sign up to my email list. If you found this video useful, like and subscribe. It really helps the channel. And by doing this, it'll allow me to cover more topics that you find interesting and make more videos at a higher quality. So please hit that subscribe button. So here we have our state manager, and we have the usual setup to create our object. You can see in here we're going to be passing in our NPC, and there will also be a current state, which I've set to nil. Next I add set state functionality. So this is what we currently have in our NPC, and I've just moved it over here to the state manager. But what we're going to want to do is now manage our transitions, and that's what we're looking at this part, is managing whether a player can go from one state to the next. I've got a few options here, I could have a huge if-else statement here, checking what all the valid states are. If you can go from walking to idle or to attacking. But I don't like that because we're back to stage one of having huge, messy if-else statements. The next option could be that each state tracks each state that's been entered can be entered from the state that's been exited. But I feel like you're now starting to put a tight coupling on some of your states. And if you think down, and if you try and think about what you potentially could do in the future, is you may no longer want that state. And if that state had become kind of core to your game, you're now potentially going through 5, 10, 15, however many states you've got to remove it. So that doesn't feel like a good option to me. So what I try and do is keep my classes small, and I do this by giving them a single responsibility. There is an acronym in software development called Solid Principles. We won't go into that. If you're interested, drop me a message and I'll do a video on it. So in terms of giving this state manager a single responsibility, what I'll do is I'm going to move the responsibility of saying what a valid state is to a different class. And I'll put that as a child of the state managers because the only place that's ever going to call it is going to be my state manager. So here I create a valid transitions method. Sorry, I said method. I mean class. I've got a valid transitions class. And in here, I'm going to change that just to say list. I've got a list of valid transitions. For our idle state, we're saying it can go to a walking state or it can go to an attacking state. For our walking state, it can go to idle or attacking. If you're in an attacking state, you can only go to the idle state. Now I add a static method, which accepts the current state, the new state, then calls the list and finds whichever item is being passed in. So what will happen here is, if the caller passes in the idle state, we're going to get that item for the list from the list. The same with the walking and the attacking. And if something's passed in that doesn't exist in this list, we're just going to return false. So assuming that someone has passed something into the list, then it becomes true. And the new state will find whatever's been passed in. Then it takes the new state to find whichever value is in here. And if the value is equal to true, this returns true, otherwise it returns false. So let's just update this module script, go back to our state manager, and we'll call in valid transitions. So what we can do now, in this state manager, it checks to make sure the current state is not nil. If it is nil, it's going to jump over to here, it'll create the new state, and it'll call enter on whatever that state is. If it has a value, it will then come into this check and say, can I transition? Passing in the current state, its name, which we haven't added yet, and the new state's name, which we haven't added yet, which will then come into this valid transition and do what I just explained. So, like I say, we haven't added the name yet. Let's go and do that. Because all of these states, attacking, idle, and walking, all inherit from the default state, that's where I'm going to add the name. I've just noticed I've got a lowercase there. I usually like to do uppercase, but there you go. We'll stick with lowercase for now. And in here, we will add name. Now, what this means is our default state is not only just accepting an NPC, it also requires the name, which means I've got to go through each one of these and pass in the name. Now, the name is really important here that the name is exactly equal, including casing, exactly equal to what's here. Now, there are better ways you can do this, but for now, it just makes sense for the sake of this tutorial that we just pass in the string. And I keep going backwards and forwards because I'm not paying attention to what class that I've gone to. So now we have an idle state there. And the last one is walking state, which I'm going to take from that. I think that might be more logical, and then I'll just check it. So valid transition, walking state. Yep, that's the same as what I've put in there. So now every state has a name, which our state manager accesses and passes into a transition manager. Well, I said transition manager. They list the valid transitions, or the transition helper class, whatever you want to call it. So our final step is to update the NPC so it uses the new state manager. First thing we're going to need to do is require the new state manager. And previously, our NPC was managing the state. That's no longer the case. What we're going to do is compose our NPC, so no longer having the responsibility living inside the NPC class, but it will have a property which can call a different class which manages that state. In this case, it's our state manager. But we will want to be able to call it via the NPC. So what we do, we provide an update functionality, which calls our state manager's update, and a perform action, which calls the state manager's manage state, set state functionality. So if we now go back to our script, instead of calling set state, we want to be calling perform action. We'll see when we run this that there's an error for the NPC on line 13. And what we can see here is I removed update from my NPC, but didn't transfer that functionality, which the state manager is responsible for, into the state manager. So now if we run it again, there'll be no error this time. And we can see that our NPC is standing. Sorry, the NPC is idle, standing still, and then a transition we try to make is not allowed. So the NPC continues to stand still. We call a transition again, that is not allowed. There's a problem here. So let's just debug this. We can step into the perform action, and the action that we're providing is the idle state. So the current action is nil, which means we're going to step over this. We'll set the new state to be the idle state. It enters it, that's fine. We call update. And now using a capital when I've put it in as a lowercase. Right. So let's change that. And right here, we're seeing the importance of convention and sticking to your convention. Because otherwise, what happens is you end up with some classes where you've got uppercase to start off with, and other classes where your property has lower cases. This is not a good practice, and I strongly recommend you don't do it. So let's try again. This time I know it's going in to here. I just want to make sure that I'm getting the names like I expect, idle state and walking state. That's great. We can resume the script, and if we look here, we get a chat script error. That's not my code, something to do with Roblox there. So let's ignore this bit and look further up. We can see we've got an idle state, the exit, the idle state, the enter, walking state, and then they're able to enter the attacking state. And that's because all of these are valid states. So let's get rid of this breakpoint. And what we can do now is add an invalid transition. So from our attacking state, we're going to try and enter a walking state. And if you remember back to the valid transitions, if you're in an attacking state, the only valid transition is an idle state. So what we're going to see now when we run this code is that a transition is not allowed. So we're attacking the player, we try to go back to walking, but it's not allowed. So we continue to attack the player and then we enter the idle state. So that's it for the state pattern. If you found the video useful, please like and subscribe. I'll see you next time.